Okay.
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 Hello, everyone. Welcome to this 10th edition of the Fluent Talk hosted by Calyptia. My name is Eduardo Silva, one of co-founders and CEO of Calyptia. And this time we have a really special guest. Today, as you know, we invest a lot in open source and we create products for observability. But actually in the open source space, we work pretty close with different companies and cloud providers. One of the major contributors also of Fluent Bit is AWS services. And today we have a very special guest called Matthew Fala, who will join us to talk about his contributions to the project and what is new and what were his last effort on making a Fluent Bit more scalable for the whole users. Hi, Matthew. Are you there?
Yes. Hi, Eduardo. Yep. So do you have any questions for me, or should I just go ahead and introduce myself?
Yeah, please, if you can introduce yourself so the audience can learn more about you.
Yep. All right. So so thank you so much for the introduction. My name is Matthew Fala. And I work for AWS, specifically on the Elastic Container Service team, on the observability section. And so really for AWS, we're trying to find the best solution to kind of send logs and send metrics from customer side just over to AWS CloudWatch, S3, different areas like that. And we found that Fluent Bit is a really great option to use for this, and it's something that customers really like to use just because of how lightweight it is, how low resource consumption it is, and so. We've been really promoting it on our end through the Firelens product, which is just kind of a wraparound Fluent Bit that makes it really easy to use with AWS ECS, which is Elastic Container Service. So I've been working really closely on the Fluent Bit integrations and trying to just make sure that Fluent Bit is performant enough for our customers and trying to resolve any problems that they're facing. So working closely with the open source community and also with Calyptia. I studied computer science at the University of Southern California. I'm just really excited to be here and answering any questions that we might have, and also kind of guiding you through the work that I've been doing recently here at Fluent Bit and also at AWS. So thank you so much, and excited for this conversation.
Great, awesome. I actually have some personal questions. How do you get involved in C development? And I think this is kind of a tricky question sometimes because nowadays not most people likes to develop in C. And that's fine, right? But I would like to get your take on that. How do you get involved with the language and to say, yes, I want to contribute to this project? Maybe
Absolutely.
That's part of your background, right?
Yeah. So I think in college, we had a lot of good experiences with C, like operating systems classes. They're generally in C. The very low level stuff. I did like to kind of work in some game development, also in C. I would say kind of as a background, I think I did work with a lot more high level languages like JavaScript, Dart, Flutter, just working on things like front end applications, and also my internship working some Java projects. So I do have more of a well-rounded software development experience, but I do like C a lot because it is very low level, very performant. We get to work very close to the operating system level, and I think that just joining a Fluent Bit or seeing what the team really needed here at AWS, it was really a lot of just C development with Fluent Bit. So just kind of refining my skills in that. I think a lot of the skills I had in C++ in the past kind of translate over pretty well, minus the classes part. I think that Fluent Bit has been the first major project that's been in C that I've been contributing to. But I think that's how all software development is. Just kind of pick up the tools that you need to contribute to whatever project it is that you're excited to work on.
Yeah, that's great. Actually, I was remembered that when talking to Wesley, one of the Fluent Bit maintainers from AWS, because he was writing the initial connectors for Fluent Bit for AWS services in Golang. I think that was CloudWatch S3 at that moment, and that's when AWS created this, was creating AWS for Fluent Bit distribution with all these Golang plugins bundle. And part of the fun story is like I think we were in Vegas with Wesley, if I'm not wrong. We were discussing, and I told him, hey, why you don't move this Golang code to C so we can get more users around, take advantage of our user space, right? And he said, I don't know, maybe we have to do this sign before signature stuff because it's needed for the services. Okay,
yeah.
let's take it. Yeah, and I remember that evening and come back to the hotel, and I started looking at sign before. There was no C library, no standalone C library, because the one that existed has many dependencies. I started crafting the one from scratch, kind of POC. The good thing is that AWS has a really good unit test framework for that, right? So if you had this kind of request, this is the expected output based on sign before. And actually, I think that I could pass like 80% or something. And I showed this to Wesley the next day. And he got excited. He said, oh, yeah, so this is awesome. Yeah, let me see if I can remember some code. And from there, Wesley took it and created all these plugins, all this stuff. So yeah, languages sometimes are, generate some discussions on stuff. I think C is perfect for Fluent Bit use case, but there are many, right? So that's really great. And well, for everybody who's watching this, when you use Fluent Bit, you might be using a different scale, right? Some people process a few hundred messages per second, others few thousands, but at a really high scale in the enterprise, they're very intensive use cases. Actually, as of 1 year ago, Fluent Bit used to work just in a single thread, like a single process, right? And it was working fine until cloud providers started asking, hey, can we get more performance? Can we duplicate this? Can we hit, 200 megabytes per second? And we implemented threading in the output. So when Fluent Bit was taking the data, processing data, and passing the data to the output plugins, what it did, and all this, when passing the data means to take this binary data, convert back to JSON to the expected format, do networking or anything that is needed to deliver this message. That is a really quite expensive task. So what we did was to create threading in the output side. And we solved the problem for 1 year. And then we came with Matt. Matt shows up and say, hey, you know what? I think that there's some saturation in the Fluent Bit pipeline for our use case. It's like the queue of the messaging is not scaling up, right? All the events are mixed together. Like there's no differentiator between timer, scheduling, network IO, or any kind of things that could touch the event loop. Fluent Bit has a main event loop where it receives events and invoke in the certain functions or plugins that need to take some action on that, right? Plus coroutines. So this is a really complex scenario, and Matt shows a problem of scalability problem that they were facing at AWS, and it was quite interesting, but also not just a problem. Actually, he came up with a solution, and this is one of the biggest topic of this kind of interview technical session. To ask Matt, how do you found this problem? What kind of approaches you were thinking? How do you approach the problem? How do you come up with a solution, and how that solution looks like?
Yeah, absolutely. So I guess the kind of depth that we would like to go into this. Do you have other questions for me, or is this mainly the topic of our discussion? So I should just kind of get into presenting sort of my research and then findings and then solution as well.
Yeah, I think it's quite flexible enough, because I would like that you share how do you approach a problem, so we can say other engineers or people looking at this session understand how do you tackle these kind of problems, how do you think about it, right, and how do you come up with a solution.
Yeah, absolutely. So yeah, just getting into kind of our detection, right? So we had a lot of customers who are sending logs. These are kind of for bigger companies. On the bigger side, they're sending, like Eduardo was saying, maybe 200 megabytes per second to various output plugins kind of at the same time. So yeah, there's Fluent Bit has a highly saturated pipeline where the data is being sent from a whole bunch of different input plugins to a whole bunch of different output plugins kind of at the same time. And we noticed that a lot of customers are complaining that they see these broken pipe errors and connection timeout errors. So we tried, taking it to our side, and we started just sending tons of data to Fluent Bit, like maybe 50 megabytes to 100 megabytes per second, maybe 1 kilobyte logs. And yeah, we noticed that we're seeing the exact same thing, maybe 50 broken pipe connection and 40 connection timeout errors, just all in the span of 5 minutes. And so that's not very good. And what that kind of means is that every time you see these errors, a network request is going to have to try again. And so you'll start seeing a whole bunch of logs being tried again. And then maybe that'll make it so that you need to be sending not just 50 megabytes, but maybe 60 megabytes because of all the retries. And then it will be a kind of like a snowball effect, because eventually you're retrying so many logs that there'll just be so much data just kind of in Fluent Bit that you'll start to see kind of bigger problems. So with low throughput, we saw Fluent Bits, very stable. But with high throughput, we saw a lot of network problems and connection timeout problems. And this was a big customer struggle for us, especially for our larger customers. And that's why we really wanted to do a deep dive and sort of target how we can solve this and help our customers through these issues. So yeah, we had a couple ideas on what could be causing it. First we thought maybe it was API, like Firehose was one thing that customers were sending things to. But we kind of talked to some other teams, and we kind of talked to some other people who are using Firehose and did some testing, sending things to Firehose ourselves, and realized that Firehose is very reliable. We don't see these connection timeout or broken pipe errors. The next thing we thought was that it was a Fluent Bit timeout problem. So we actually published a PR to adjust the timeout, or to kind of resolve what we thought was the issue. It turns out the timeout was not flawed in Fluent Bit. The timeout was working fine. So the last thing that we thought could have been the problem is that coroutines are actually hanging. So what that means is that when you make a network connection attempt, then it will start the network connection. The network activity will complete very quickly, but then the code will stop. It will kind of pause for a while, and it might pause for like 1 second, 5 seconds, or even 10 seconds, and finally when it comes back, there's already kind of like the network connection that was made to whatever upstream source it is. So that could be Firehose or S3. That network connection would be stale. And we found that this was, what was actually causing the problem. So we really wanted to try to get into what exactly the issue was. And so this is just kind of a picture of what we found. The network connection, the network activity, if you were to kind of monitor packets coming at Fluent Bit, kind of goes very quickly, right? It's like 100 milliseconds or less or something like that. But then the code, when it makes that network request, it takes over 10 seconds sometimes to resume. And that amount of time when you're trying to do a couple of different requests at the same time, it's long enough that causes some broken pipe and connection timeout errors. So that was kind of the problem. And just kind of looking at the data, you can see this is kind of, we graphed the broken pipe and connection timeout problems over time. And you can see they're very highly clustered. You can kind of see it in several different, like 5 different clusters for the broken pipe. So we also kind of mapped that to the amount of, sort of simultaneous code that's sort of running at the same time, and we realized that there's some correlation between this. So we were trying to really get to the bottom of it. But yeah, in order to get to the bottom of everything, we had to really dive deep into the event loop. And so yeah, I don't know how deep we should get in this conversation, but we can definitely go through some parts of this. So yeah, we are going to give a more in-depth talk about the event loop at FluentCon. So if you'd like to sign up, I think there still might be time. We'll dive really deep into the event loop and some of these problems and some more details of how we solved the event loop. But yeah, maybe we can just get into kind of a high level perspective of what the event loop is and some of the problems. What do you think, Eduardo?
Yeah, this is like kind of, we're gonna make some examples, right? I don't know if when you go to take an airplane, you go to the supermarket, there are different kind of lines, right? And when you're going to, you need to provide a good service to the people who's there, right? On this case are the events, right? So the event loop was deciding, well, there was no order, right? First in, first out. And sometimes that order was a bit of a mess. And all this event-driven programming and the event loop side in Fluent Bit actually was, the workflow is like this. For example, if you need to send data to somewhere, we take the data in. I'm going to just talk about the output side as a context. So you got the output plugin, and you have a flash callback. That flash callback is in charge to do the whole operation, to deliver data, right? The first approach from asynchronous programming that we did is like every flash callback runs in a different coroutine, well, in a coroutine or a lightweight thread or whatever you wanted to call it. And the interesting concept is like the flash callback can have many operations. But imagine that you're going to do, for example, an HTTP request because you're going to connect to an HTTP endpoint. So what are the steps, right? The first one will be try to connect a host that implies to make a DNS resolution. Once do you know what's the IP address when you want to connect from a code perspective, you need to perform the TCP connection. And once that is open, maybe it comes after that a TLS handshake because you're going to use a secure channel. And when that is established, then you can start transferring data. On all these steps, there's always one symptom. It's like you ask to do something to the kernel, and pretty much you just sit and wait until the kernel returns back to your code, and then your code continue executing. By having coroutines and event loop, what we try to do is like we're going on this IO operation or maybe DNS query is like ship the query, ask the kernel to buffer the data, and we just not sit and wait. We just, from a coroutine perspective, we just return to the event loop to continue doing other work. And once that operation has been completed, we just return to the same code. And this happens in a very smooth way. Actually, the user does not know when a coroutine has been suspended, yielding, has been resumed. This is pretty transparent. But as you can see, in just one output plugin, there's many events happening, right? So all these events, and if you have multiple output plugins, you have multiple flashes, retries, you can see that, you can think that you have a lot of congestion in the event loop at some point. And this is where Matthew work comes in to save the day and say, now we're going to scale better, we're going to have priority queues. And there was a really good approach. He said, we're going to have a FluentCon on May 16 in Valencia, but we're also going to stream, if you cannot attend in person, we're going to stream all these sessions virtually. So please just sign up to FluentCon and you will get access to this great presentation. And yeah, actually, before to let you go, I know that you have a very tight schedule. This day it's a Friday for you. I wanted to know, it's like, how was your experience starting contributing to an open source project? Because you know that each line that you modify and gets merged has a direct impact on users.
Yeah, absolutely. Yeah, I think that it's a lot of just kind of testing. We really needed to find a better way to test Fluent Bit because just kind of writing some commands in the terminal to send TCP packets to Fluent Bit, it wasn't really going to scale well, especially if we wanted to send very high throughput logs and monitor problems or add some instrumentation to Fluent Bit. And so we built out this test framework called Firelens DataJet. And we also have another test framework as well. But Firelens DataJet just kind of allows you to write down in a single JSON file a whole bunch of tests, and it separates the problem of sending test data to Fluent Bit into outputs, data generators, and sort of the data sending array, right? So you can have these sort of groupings kind of connected together, either in like a synchronous fashion or an asynchronous fashion, and you can tell it to repeat several times. And so just and then also we had it so you can wrap these sort of configurations in Fluent Bit executors. So you can execute Fluent Bit and then start sending high throughputs of data and then collect all of the kind of metrics and results in just one place. And this allowed us to just be able to configure like 15 tests to go run and just go ahead and let it run overnight and come back and monitor all the data, plot in Excel or something. And so doing this really allowed us to sort of expand our testing in such a way where it wouldn't be so much manual overhead. And I think at one point in time you're asking me like, oh Matt, could you run all the tests again? with one worker instead of 0 workers and 5 workers, because that's what we were testing things before. And I think if we were doing all the testing manually, yeah, that could have taken like a week or something to do. But just because we had this sort of system put in place, we said, oh, okay, great. We'll just change some configuration values in our testing framework and just go run it again. We waited overnight, and yeah, we just came back in the morning and had all the data just ready for us to analyze. And so I was able to ship you guys, and also like my manager as well, just sort of the data on one worker, like 14 graphs or something. And just being able to sort of take a look at that together and sort of analyze those results. Yeah, I think that just sort of leveraging tools that can help to analyze things and to make testing more reliable and sustainable, I think is one of the biggest ways that we were trying to make the code that we're writing rigorous and sort of well tested and all of that. And also writing strong unit tests as well. I think that's another big part of this process, and code review as well. So I think there's several different pillars of this. I think testing, unit tests, and then also code review. Those are kind of like the 3 pillars of open source, code resilience and stability.
Yeah. Actually, get all these tests right, that has been a challenge. Actually, ourselves at Calyptia, we're building some benchmark framework, which is really basic to run locally. Amazon, where you guys are building something that to be more integrated with Amazon services. It's been open source right now. I think that, well, Google on their side, they're working on one testing framework for Fluent Bit too. So that is really great. Actually, there's no one performance framework that fits all use cases, but this is normal. Let's say when we were talking about this performance issue, let's try workers, let's try this, trace this. And usually users face the same thing, because sometimes users, when going to choose an agent, right, they just read a blog post or some post that say, yeah, A is faster than B, and that's it. And when you go and they go to deploy the solutions, they found that sometimes things are not true, right? And because your data that you have in production is really hard to mimic, right? It's really hard you don't know what will be the load peak, the data flow. Maybe it's not just about the number of messages per second, but also the size of messages. You can have few messages, but bigger messages is different thing, right? And that alter your pipeline in different ways. But I think that when you join contribute a project like this, when you have to deal with data movement, coroutines, threads, networking, at least for me, it's really interesting, because you need to touch different parts and understand how the operating system works, right? Because at the end of the day, you want to provide a really good experience. And
yeah, we have that analogy, right? Yeah. We have that the thought framework analogy. I don't know if you want me to share that, but maybe that would help some of the developers who are out there. Sure. But yeah, please go ahead.
Oh, no, go share it, please.
Oh, yeah. So yeah, one of the things I shared with Eduardo was kind of like that thought framework. We had like an analogy that we're using here at AWS to really think about the Fluent Bit event loop and the coroutines. And yeah, I think that when we talk about these things, just from a higher level perspective, it can get kind of like lost between, like blocking operations, asynchronous events, threads, coroutines, CPU, and all these things can get a little bit convoluted. So we kind of created an analogy that allows us to think of the solutions and the problems all kind of in a very simple way that everyone can understand, whether you're working on Fluent Bit or not. And so, yeah, if you want to hear the analogy, it's pretty quick. It's just really the following here. So you have people who are standing in line to work on a form that's on a desk, and have some people who are standing at a phone booth and they're phoning friends, and that's really it. And so, kind of talking about the Fluent Bit system, what's going on here? Well, the desk is like the CPU. The forms are like your code that you're working on. So Eduardo mentioned how we have kind of some event-driven programming paradigm for Fluent Bit, where you have coroutines that are just waiting to get the CPU to start working on their code. So that's kind of like these people who are standing in line. Every single person is like a coroutine. So you have these people who are standing in line. They're like the coroutines in Fluent Bit land. You have the desk, which is the CPU. You have the forms, which is the coroutine code that the coroutines are waiting to work on. you have the people who are phoning a friend. So this is like the coroutines that are suspended. They're waiting to make a kind of like blocking asynchronous call, a network call or something. You have the phone booth. So this is the not ready list. So all these people who are making these blocking calls get to go wait in some not ready list. So Fluent Bit has this concept as well. And finally, you have the line. So this is kind of the FIFO. So Eduardo mentioned the FIFO event loop. This is kind of like what we had in Fluent Bit 1.8 before we added some new changes to give some prioritization. But in 1.8, every single coroutine was standing in just one line for the CPU. It doesn't matter how important you are. It doesn't matter whether you started your work or not. Everyone's waiting in the exact same line to get to the CPU. So just kind of taking a look at what happens, you're a coroutine, you have some work to get done. Maybe it's sending, information to Firehose, right? So you get your code at the CPU. It's just one coroutine is working on it. Everyone else is suspended. Everyone else is just kind of waiting in this line. You have to go phone a friend. So you get to a question that needs a network call. So you go step out of line, you stand in the not ready list. And then the next coroutine gets up to the desk, kind of switched in because Fluent Bit realizes that the other person has left. And so he gets to access his code, he starts working, and the process continues. And then finally, when a phone a friend, when a network call completes, that coroutine gets to stand back in line, he gets to wait for the CPU again. So this is the entire kind of Fluent Bit process of making network calls. This is the Fluent Bit process of these coroutines waiting for the CPU and getting to run their code in kind of it's almost like a multi-threaded fashion, except there's only one thread and only one of these coroutines are doing work at a given time. Like Eduardo mentioned, there's an issue with this FIFO queue. Let's take a look at what that issue is. So this is kind of where the real problem is that we were talking about earlier. This is the root cause, where you have all these people, they're waiting in the same line. And unfortunately, because there's no prioritization, this line gets extremely long. And there's, it doesn't matter who you are, you have to wait in the exact same line. And an issue with the, just system in general is that if you make a network call and you stand back in line, and you take too long to get to the CPU, then you forget what your friend told you. It's like you forget it. So you get a broken connection or a broken pipe or a connection timeout. So kind of like Eduardo was saying, you might start some SSL or TLS connection, and like you have to make some more network calls after that. But then you get like a broken pipe because you just waited too long to get to the CPU after finishing your network call. So this is kind of like what we're talking about from the customer standpoint, where you finish your actual network activity, but then for the code to start running again, it takes like 10 seconds because they're waiting in this line to get to the desk. So when you get to the front of the desk, you have some issues. You have broken pipe or connection timeout. So where are these people coming from? Well, they're coming from kind of the input plugins. So there's just some list. We're calling it the hold line. And like Eduardo mentioned, there's this flush operation, right? And the flush takes everyone from the hold line, everyone from these kind of like input lists, and it just moves them all to the same line. And you can see this line gets very long, and we're seeing maybe sometimes it gets from like 60 to 100 different coroutines. They're just waiting in the exact same line, and that takes a big toll on how long it takes to get through this waiting list to get to the CPU. All right, so how are we going to resolve this? Well, so prioritization is the answer. So we added a new policy. We thought it would be a good idea if instead of taking everyone from the hold line and moving them to the desk line, just whenever they show up. So every time you get some new data from the input, you move them to the CPU, you move them to wait for the CPU, which makes the CPU line super long. Instead of doing that, we're going to tell you to hold. We're going to say, hold on, let's wait till everyone in the CPU line finishes. If you haven't started yet, if you haven't started your code yet, just wait. And once that CPU line gets to 0, because all the work is completed, then we'll start admitting you. So that's where the priority queue comes into place. So this kind of prepares us for the solution which we added, which is to add some priorities. So if you are a coroutine that's inactive, you haven't started yet, you're waiting to be flushed, well, we'll give you a priority that's lower than the coroutines that are already started and maybe doing some network calls. Maybe they're waiting to get back to the CPU after they finished phoning a friend. So yeah, the one on the left and the one on the right have different priorities. So this is what we added. We gave the people who made their network calls and are waiting to get back to the CPU to complete their network call, we gave them a very high priority. So that means that they'll be prioritized. And we gave the people who are inactive a very low priority, right? So these are coroutines that haven't even started yet. We give them very low priority. And in so doing, we make sure that the line on the right-hand side is very short. And we saw tremendous results in this. Kind of skipping to the results, we saw across the board, like 96 to 100% improvement. We saw connection problems going from 51 errors to 2 errors, or 51 connection timeout errors to 1 connection timeout errors. We saw the number of coroutines going down by a factor of maybe 3 active coroutines, that is. And you can see that from before, the data shows that there's a very high amount of coroutines, maybe like 30. And when you see a big spike in coroutines, you see a big spike in errors following it, kind of in these red boxes. But then, with the new solution, we're seeing, across the board, like 10 or less coroutines often, and almost no errors. And so this tremendous improvement. See, we only have like 3 errors here, whereas in the past we had a ton of errors in the blue and silver. So yeah, it's just seeing tremendous improvements all across the board. And the reason why is because we added this kind of 2 different lines. So what's the new paradigm? I guess the old paradigm was, start all the work as soon as possible. So if you have a bunch of work to do, start all the work as soon as possible. The new paradigm with the priority queue is complete the work that you've already started. So if you started some work and you're doing like a phone a friend, you're making a network call, finish that stuff first. And then if you need to do other work, we're not just going to let the CPU be idle, we're going to start the new work. So that's the paradigm shift that this priority queue solution sort of implements. And it is, the reason why, we think that this is something that's really going to help in the future, Fluent Bit be more scalable, just so that we can keep the sort of latency between, waiting for the CPU and actually getting the CPU at a minimum. So yeah, thank you. That's kind of the improvement that Eduardo was alluding to, and some slides to kind of help. But we'll go into a deep dive of exactly, what this means in the FluentCon. And yeah, maybe we can also send out a link or attach it to the comment section as well. We have a link to this video. All right.
Yeah,
so
that would be great. Actually, well, just so everybody to let you know, all this work is in Fluent Bit 1.9. So if you are using 1.8, yeah, the performance 1.9 will be on what 1.8 was doing. And actually, I think that this priority thing works for such as live, but also code. So it's really good, this analogy is like, yeah, if you're doing one thing, just finish it, right? Don't jump into other ones, manage priorities. And yeah, that's really, really, really good. And just, I don't know if you wanted to add something before the wrap up this session today. Any advice for the young open source developers that want to get into open source? Doesn't need to be this project, but general advice based on your experience?
General advice. Yeah, I think it's really to make a lot of proof of concepts first. Make very rough proof of concepts first, that sort of prove that the idea is viable, and then polish it. But I would say get the proof of concept first. Show it to whoever it is that has the decision making, like yourself, Eduardo, or Leonardo, or other people at Calyptia, to get them on board to point you in the right direction to get that from the proof of concept to the actual final solution. Because I think a mistake that I've made in the past is really trying to perfect something at first and then showing it to people, and then kind of having to see sort of like, oh, okay, it kind of doesn't align completely with the vision of Fluent Bit, and then having to sort of revise things and sort of repolish things. So I think proof of concepts are really great because it allows you to not invest too much time, but just give a certain idea. And then you're totally willing to throw away the idea, perfect the idea, change the idea completely before getting to that, final result that we're willing to add to Fluent Bit to, make it exactly what everyone has in mind, for the vision of this, full community. So I would say definitely proof of concepts are a good idea because we were showing in the beginning how we thought it could have been three things. It could have been an API problem, a timer problem, or the event loop issues. So we actually did create a proof of concept for, I guess, each of those different problems. Yeah, we had some, like postman requests for testing a Firehose API. We actually made a PR to do timer things. So the timer, we noticed that timer events would get queued in that event loop, just like all the other things. So we noticed that it's kind of weird. Like if a task, if a coroutine was queued, like 1 second, but then it actually got run after 100 seconds, then the timer might judge it incorrectly. Like it might think that, it's 100 seconds out, even though the event was queued after 1 second. And so we published, a PR to say, okay, let's instead of tracking when the coroutine gets run, let's track when the coroutine gets added into the event loop. So we did that, but it actually didn't help because instead of seeing connection timeout problems, what we're seeing is broken pipe problems. So it actually did matter that the coroutine was getting run in 100 seconds rather than 1 second. So yeah, in one sense, the timer was kind of incorrect, and we were correct in thinking that. But the incorrect behavior of the timer actually makes sense. The timer should be tracking when the coroutine is running. The timeout should be tracking when the coroutine is running, not when the coroutine is added to the event loop. So that proof of concept actually showed that it's not beneficial to track when the coroutine was added to the event loop. It is beneficial to track when the coroutine gets run. And that's what it's already doing. So we got to just quickly throw that idea away, put that PR just kind of in our archives, and then move on to the next problem that we thought it could have been, which is the event loop hanging and sort of prioritization solution. So I think proof of concepts is probably my best sort of like piece of advice to anyone who wants to contribute.
Nice. Actually, that's really interesting. So one of your POC helps you to determine where the problem was not located.
Yeah, absolutely.
Right. So absolutely. Yeah, it happened to me. Yeah, also happened to me the whole time. Right. And sometimes these POCs, it's like sometimes it's like, oh, should I write it? Should I not write it? But it's a really good way to validate things. It's like unit testing, right? I don't like to write unit testing, but every time that I write it and then I find my own bugs, I'm thankful for writing those unit tests. So POCs are really interesting. Actually, most of the projects start as a POC. For example, Fluent D, the parent project, started as a POC. The original idea by Sada, the creator of Fluent D, was to make it in C++. But he needed to prototype something fast. So he said, oh, I know Ruby, and he's an expert in Ruby. I started reading Ruby. He already wrote the message epoxy library at that time. So he just created this prototype in Ruby and started working well. And the project started to grow. And well, Fluent Bit is everywhere nowadays. Actually, when in the Fluent Bit story, that is a similar thing, right? It's like, should we write something in Go? I'm talking about 7 years ago, right? Something in C. I said, let me prototype something in C, maybe. No, because that might take so much time. Okay, I just took a week and wrote the PO, the first Fluent Bit. I already wrote some event loops stuff before with a web server. So I had many components. So it was just about, hey, let's collect as an input metrics from the kernel, something simple stuff that exists in the file system, right? Because the metrics are in the file system. And then send it out to standard output with the event loops, collecting a timer, send it out. You can see that in the first version of Fluent Bit. And yeah, that POC started to grow. It becomes a solution, and here we are after a couple of years. So really good advice. Story. Yeah, and many people tell you it's like don't waste time on that. Actually, that's in general, right, for life, not just software code. POCs are a great way to do it. When we were at some conference at the beginning, an open source conference showing Fluent Bit, most of some companies very well known. I remember one guy was from a company that wears a red hat. Hey, how many lines of code the project has? And that moment was like 10,000 or so. We said, oh no, it's not ready. It's not ready. We need more time. Yeah. Right. So there are different ways for people to measure things, but I think that one of the keys is just to be persistent on this, creating POCs, trying to prove, fix the problems, and so on. So, but
yeah, I guess that's a good question to have in general for the Fluent Bit community, because Fluent Bit has been something that's just so lightweight. But it seems like the sort of vision for Fluent Bit as you're going into the future with adding all these like Lua adapters and JavaScript engines and other things like that. I just wonder about kind of like the Fluent Bit's direction. Is it heading towards more of like a full sort of system that's less lightweight and more just kind of like has a whole bunch of features? Or are you going to try, do you see in the future, like kind of in the vision that you're going to keep it extremely lightweight, like zero dependencies, kind of like what you had envisioned, I guess, looking back?
Oh, that's a really good question. I'm going to connect the answer based on patterns from the past. For example, you talked about, hey, you add a Lua scripting, all that stuff. When do we add a Lua scripting? It was on a time that Fluent Bit was not famous on the cloud space, but it was a time when in Europe, GDPR was hidden. GDPR was a lot of policies and securities in Europe where you have to obfuscate data. You cannot share, for example, credit card transaction numbers in certain scenarios or move them over the network if they are not encrypted, stuff like that. So I was in a conference talking with the early Fluent Bit users, and one of them, actually two of them from a company from Germany, told me, hey, we are testing out Fluent Bit. We're moving some logs from our system, but we have a problem. GDPR is coming, and we need to obfuscate the data because some fields are the credit card numbers. And I told him, maybe write a plugin, to obfuscate data. And they said, yeah, but sometimes we have conditionals. Like if this record contains A, B, or C, we have to obfuscate in this way, otherwise take the other action. And I was quite little familiar with Lua. Hey, maybe we can do some Lua scripting. So, and that's where it started, where you listen to the user, because it was not a vision, right? The user tells you, hey, this is my problem. And then his problem was not how to obfuscate data. His problem was, how do I bring my business logic into the agent, which is different, right? And for example, if we take a look at Fluent Bit at Kubernetes, right? Fluent Bit started for embedded Linux, for IoT. It was not meant for Kubernetes because Fluent D started at the same time that Kubernetes was from that area. But users started struggling with Fluent D because it was too heavy. And some people started trying out Fluent Bit. And they asked us, hey, why don't add a Kubernetes filter, tail? Because tail was not there from the beginning, tail came after 1 to 2 years. Why we can send the data to Elasticsearch, to this new fancy database, talking years ago, right? And all of this is feedback from the users. Now, this was not meant like a vision about, let's do it on this way for all these years. It was always a continuous interaction with the users. Now, if we connect this, what's coming for the future, we had to understand, for example, if you take a look what people want to do with these kind of tools, they always start with the question, how I can analyze my data? The first answer, oh, you need to start data in your database so you can run queries. Perfect. But before that process, you have the old problem. How do I collect my data? Okay, this is the agent. Now, user has another problem and say, oh, can I move certain analysis part to the agent? Which now is called edge computing, or they're moving analytics to the edge, to the left, where the data is being generated. And actually, in the Fluent Bit project has happened something really interesting. It's like we have input filters, outputs, plus other small components. But in the filter side, some of them are special Lua scripts to do analytics, or they are using the SQL stream processor that we have. But actually, there's a pattern now that where people can move that processing even more to the left, to the input plugin. Right? If you ask me where Fluent Bit is going, not because of the maintenance, but because it's going because of what the market needs, is like have more processing where the data is being generated, even inside the agent. Right now, we're thinking about how to make input plugins in a thread way, how to make scripting in the input plugin natively. So no matter what you add, you can add some scripting rules. What are the values? Less saturation on the main pipeline because it's running in a separate thread. Secondly, you can add, maybe you can do Lua scripting. It's like to attach the filters, right? But running them in a separate context. Or maybe run a SQL query, because that is for the user, right? The user is getting the data and they can say, I just want keys A, B, and C, no more. So maybe you can use SQL. We support SQL, so we can do that very easily. So where we're heading is like Fluent Bit is behaving like a platform for data processing. It started as like an agent for log forwarding, right? But now it's not just logs. Since 1 year, we do metrics collection. We are replacing some of the Prometheus scrapers, and we can do connection with Prometheus. Now we are starting supporting OpenTelemetry, because this one problem in the industry is like few people care about performance. Well, most of people care about performance, but few people execute on optimizing the software, right, to run at a very high scale, right? And I think that tools around are not well optimized for performance. Yeah, they do the job, but they're not optimized. So when they hit certain scale, yeah, they got stuck. And then they come to Fluent and say, hey, can you do this on this way, or improve it? Yeah, we can. I know it's not because it's written in C. And I think that there's an architectural thing, because you can run slow code on any language, right? It's easy. But I think that the fundamentals of performance in Fluent Bit has been there for years. Always high performance, optimize, try to, if you can cache the memory, don't reallocate the memory, try to do it, right? So where we're heading, I would say stream processing, like a platform. Right now at Calyptia, we are creating a whole new interface to create Golang input plugins in Fluent Bit, right? And this is like, oh yes, people say, oh really, is it possible? Yeah, we're working on that right now. And this is pretty much to provide more options to the users where they can create their own POCs without learning C, right? And sometimes, as what happens to Wesley, yeah, he wrote the stuff in Go, and then he migrated everything to C, because it's not because Golang versus C, it's because Golang has its own API, right? Their own interfaces. But if you use the architecture of Fluent Bit, by using Fluent Bit interfaces, you might achieve better performance. That's it. So we're trying to bring those concepts up to Golang. We have some small POCs of WASM 2, how to run Fluent Bit in browser, but those are very early stage yet.
WebAssembly?
Yeah.
That's very, very amazing. Yeah, I think that's such an awesome sort of paradigm to have, where it's expandability, adaptability, and just allowing for the users to totally customize things. I was recently hearing something about kind of like how JavaScript added so much to the web experience, because before that, people couldn't add on the kind of scripts and sort of extensions to the web experience with just HTML and CSS, and just sort of having JavaScript be there to give people kind of like a customizable experience, just change the game. And I think for Fluent Bit, it kind of is kind of like a very, very similar concept where you have this really well built out pipeline for data, and a structure, a framework for processing that data. But then you're also giving the users kind of like that JavaScript like experience to be able to write their own code to modify that data and just whatever they want, they can sort of add it in. And I guess like JavaScript, and sometimes like jQuery or something, or some things like TypeScript, these things can get put into JavaScript in general, like the standards. And I guess that's kind of like what you're saying, where people can bring things from Go, put them into C, to really make things super performant and just kind of baked into the platform. But I think it's so nice to know that it's so extensible, that anyone can add this code to modify this pipeline and to get their custom experience. I think that's such a powerful idea and a powerful concept, and a great direction for Fluent Bit in the future. So thank you so much for sharing that vision.
Yeah. Actually, for example, for this WebAssembly or WASM journey, there are two angles, right? One of them is how to run Fluent Bit in the browser, right? So from a web app, you can prototype and do fancy stuff, testing pipelines.
Mm-hmm.
And the other is like from a developer perspective, how do we allow more than Go and C to bring more business logic into the agent, right? Because you can compile Go to WebAssembly, Rust, C, so you can do whatever you want, right? Now, I know that other projects tried this some time ago, and they found some very performance penalties. But sometimes you need the POCs to make it work first, right? And then optimize. I think that, yeah, we all know that premature optimization does not work all of the time, but it would be really interesting to see this WebAssembly stuff taking up some time. So if you want to help with that, it would be great.
I'll talk to my manager.
Awesome. Yeah. No, and well, thanks to your manager and to AWS for let you contribute to open source. I think that AWS has contributed a lot, and we'll appreciate for that effort. Okay, so I think that we extended a little bit this Fluent Talk. I'm really thankful that you could join on this session, and for everybody, please join a FluentCon in May. And also these Fluent Talk sessions are happening every Friday. It's usually 2 p.m. Pacific, but sometimes we are switching the times just based on the speaker availability. So feel free to just connect and send your questions on the chat. Well, Matt, thank you so much again for joining this session, and we hope to see you soon in Valencia.
Yep, glad to be here, and thanks so much, Eduardo. Bye.
Okay, bye.